Now in this lecture, we are going to create insert method for inserting a node in double linked list. So inside double linked list class, we are going to create a new method which is called insert DLL. So I'm going to declare our method like this. So our method will be public void insert DLL. So we are going to create this method based on the algorithm that we explained in our previous lecture. So in our algorithm, we have said that our method will take two parameters. So the first parameter will be integer node value. So we are setting it to integer because when we are creating double node over here, we have said that double node's value will be integer. So that's why when we are inserting a node, the value should be the integer. So that's why this parameter is integer value. Then we are going to create another parameter which will be integer as well, location parameter. So this will be the index of the node in which we want to insert a new node. Now then, the first thing that we are going to do, as we said in our algorithm, we are going to create a new node and assign a node value to this new node over here. So this new node will be created based on this double node class. So here it's going to be like this. So I'm going to create new node based on this double node class. New node will be called new node and it's going to be like this, new double node. Then the next thing that we are going to do, we are going to update the value of this new node with the node value that we are receiving as a parameter. So value will be set to node value. Now after doing so, the first thing that we are going to do, we are going to check that if head equals to null, then in this case we are going to call this create DLL method with the node value that we are receiving over here. Otherwise we are continue to check location parameter. So here the first if condition will be like this. If head equals to null, in this case it means that our double linked list does not exist, so we can create double linked list based on create method that we created over here. So this is create method. So as a parameter it will take the node value parameter that comes from this method's parameter. Then after creating double linked list, we will have one node in our double linked list and this node's value will be the node value that we are receiving from this parameter. So it means that we will insert one node in a double linked list. So then I'm going to put return over here to stop our method over here because it doesn't make sense to continue because we have just created a double linked list and insert a value to it. Now then the next if condition is we are going to check that if location parameter is equal to 0, it means that we are inserting a node at the beginning of double linked list. So this means that I will put our else condition like this. Else if location is equal to 0, it means that we are inserting a node at the beginning of double linked list. So this means that we are going to insert this new node that we created over here at the beginning of double linked list. Now in this case, we know that when we are inserting a node at the beginning of double linked list, the first thing that we are going to do, we are going to set this new node's next reference to point to first node. So this new node's next reference will point to first node. Now we know that in head reference we have first node's physical location. So that's why if I put new node.next equal to head, it means that we are creating a link between new node and head. Then this new node's previous reference has to point to null because in this case, in case of double linked list, the first node's previous reference is always null. So I'm going to set this new node's previous reference to null. Then the next thing that we are going to do, we need to create backward link between the current first node with the new node that we are creating over here. Now we know that current first node is located at the head. So if we put head previous, we are accessing the previous reference of the current first node and we are setting it to newly created node. Then at the end, we are going to set head to point to this newly created node over here because this node becomes the first node in our double linked list. So with this, we have completed inserting of a node at the beginning of double linked list. Then we are going to continue to the next if condition zone in which we are going to check that if location parameter is greater or equal to size of the double linked list. In this case, it means that we want to insert an element at the end of double linked list. So this size property comes from the property of double linked list. So as we said before, when we are creating size, if we insert an element at the double linked list, we are increasing this size. If we are deleting an element from the double linked list, we are decreasing this size. So in this case, we will say that if the location parameter is greater or equal to size, it means that we are inserting an element at the end of double linked list. Now, when we are inserting an element at the end of double linked list, the first thing that we are going to do, we are going to set next reference of this newly created node to null. Because in case of double linked list, the last node's next reference always points to null. So that's why I'm going to put new node.next equals null. Then we have to create a link between current last node with the newly created node. So we know that tail now points to the current last node. So if I access tail.next, we are going to access the current node's next reference. So I'm going to set it to new node. Then the next thing that we have to do, we have to create backward link between new node and the current last node. So if I set new node's previous reference to tail, in which we have current last node, we are going to create backward link between new node and current last node. So if I set current node's previous value to tail, we will create a backward link between newly created node and current last node. Now at the end, we know that in case of all types of linked list, tail has to point to last node. So that's why I'm going to set tail to new node, which will be our new last node over here. Now with this, we have completed inserting of an element at the end of double linked list. Now then we are going to continue to the third case, in which we are inserting a node at a specified location. Now here in the else condition, I'm going to write that condition. So the first thing that we are going to do, we are going to create temporary node, which will get the first node's value. See, if I assign a head to it, it's going to start from the first node. In each iteration, it's going to continue to the next node until we find our location. So to do so, I'm going to create index variable over here and set it to 0 because we are going to start from the first node. Then inside while loop, we will write while like this, index is less than location minus 1. So this means that we are going to traverse until we find the node which is located before the location that we want to insert a new node. Then in this case, in each time it's going to continue to the next node. So that's why I'm going to set it temp node equals temp node.next, and index will be increased by 1 in each iteration. Then outside this loop, I'm going to write our logic, because when this loop is finished, we have reached to the location which is before the specified location that we want to insert a node. So that's why I have to create a link between current node with the newly created node and newly created node with the next node. So that's why what I'm going to do over here is, the first thing that I'm going to do, I'm going to create backward link between the new node and current node. Now we know that current node is the temp node because we have reached to the location by setting each step temp node equals to temp node.next. So here I'm going to put like this, new node.previous will be temp node, which is a current node in this case. Then with this we are creating a backward link between new node and the current node. Then we are going to create a link between new node and next node. So to do so, I'm going to update the next reference of the new node with the temp node's next reference. So we know that temp node is the current node, so the temp node's next reference is the next node. Then we are going to create a link between temp node and new node, which is current node. So we have to create forward link between the current node and the new node. So that's why I'm going to set the current node's next reference to new node, so which will be like this. Then at the end, we have to create backward link from next node to the new node. So to do so, we know that now in the next reference of the new node, we have next node. So if I access the next reference of the new node and access the previous reference, it means that we are accessing the next node's previous reference. So if I put something like this, new node.next, in which we have the next node dot previous, we are accessing the previous reference of the next node, and we are going to set it to new node. With this, we are creating backward link between next node and current node. Then at the end, we are going to increase the size by 1, because each time we are calling this method, we are going to insert only one node in our double linked list. So that's why we are increasing size by 1. Now with this, we have finished insertion method in double linked list. Now let's see how this is working in practice. So inside main Java class, we have created our double linked list like this. So here I'm going to call our insert method to insert elements in various locations. So first I'm going to insert at the location of 0, then I'm going to insert at the location of, for example, 1, the value will be 3 and the location will be 1. Then I'm going to put some value that is, for example, greater than the size of the double linked list, 7. So if I run our code, you will see that when we are printing the head value, it's printing out 2, because first we have created our double linked list with the value of 1. So in this case, we have only 1 node in our double linked list. Then we have inserted 2 at the beginning of double linked list. So that's why it's printing out over here the first element value. Now, if I put over here, for example, head.next.value, in this case, it's going to print out second element's value. Now we know that the second element's value is 3, so it should print out 3 over here. So as you see, it's printing out 3 over here. Now with this, we have seen that our method works the way that we want. So all 3 cases have been implemented successfully. Now let's see what's the time and space complexity for this method over here. Now here, as always, we are going to start from the first line of this method. So in the first line, we are creating a new node and assigning value to it. Now in this case, these 2 lines of code will take a one-time complexity, because here we are just creating a node and assigning a value to it. Now then we are continuing to the this if condition. So inside this if condition, we are checking head value if it is equal to 0 or not, and then we are creating double linked list. Now we know that when we are creating double linked list, it takes a one-time complexity. So this means that this if condition also will take a one-time complexity. Now in the next if condition, we are checking that if the location parameter is equal to 0 or not. So then if it is equal to 0, we are updating the next reference of new node and previous reference of new node, and we are creating a link between head and new node and vice versa. So these 4 lines of code over here will take a one-time complexity one by one. So if we combine all these 4 complexities over here, we are getting a one-time complexity. Now same logic is applicable over here. Here we have another if condition in which we are checking location parameter with the size of double linked list. Then we are doing some assignments over here. Now if we look at these assignments one by one, we can see that these assignments takes a one-time complexity. So this means that this if condition also takes a one-time complexity. Now when it comes to else condition, here we are creating temporary node and assigning head value to it. And then we are creating index and assigning 0 to it. Now it's obvious that these 2 lines of code will take a one-time complexity, because these are basic assignment statements over here. So we know that assignment statements take a one-time complexity. Now when it comes to this loop over here, you see that in the worst case, we are looping almost through all elements of the double linked list. So this means that this loop over here will take o n time complexity, because if the number of elements in double linked list is n, and if we put location n over here, we have to loop through until n-1. So in this case, it will take o n-1 time complexity. Now if we eliminate constants from here, it will get o n time complexity. Now this loop over here will take o n time complexity. Even though we have some assignments inside this loop over here, these assignments over here will take o one-time complexity, but at the end, this loop will take o n time complexity. Now then, we are doing some updates to the references of this new node and current node and next node. So these 4 lines of code also will take a one-time complexity, because these are just simple assignment statements over here. Now at the end, we are increasing the size of double linked list. So this is also another assignment statement over here, and this also will take a one-time complexity. Now if we combine all these complexities over here, we get o n time complexity, because all these o one-time complexities over here are non-dominant terms, so we can easily eliminate them and get o n time complexity. Now insertion of a node in the worst case in double linked list takes o n time complexity. Now you might be interested, what is the space complexity for this method? The space complexity is O1, because in this case, whenever we are calling this method, we are just inserting one node to the space, so that's why it takes O1 space complexity. So hopefully everything is clear about this method. Now with this, we have come to the end of this lecture. So in this lecture, we have combined all 3 cases of insertion in double linked list. So we have combined them together and created a single insertion method in double linked list. So hopefully everything is clear about this lecture. So see you in the next lecture.